I would like to share um, my presentation I created. I'm not a good speaker, so I will show my presentation and I will go through my uh, life story. So bear with me, please. Do you all see my screen?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So I created this presentation for you all. Like I said, speaking is too hard for me. So I made this slide like topic is my road to space. Mr. Rijendra Pal Thapa already explained my background, and I think it was too much for me to digest. Thank you so much, and I'm very honored to be here today with you. Um, as you know, my name is Mizanul Hoq Chowdhory. I'm from MIT Space System Laboratory. I am responsible for MIT Zero Robotics. Currently, I'm doing research on NASA's Astro robot. I would like to start by thanking the organizers, judges, scientists, students, and their families for making all this possible. My special thank to Mr. Rijendra Thapa, who invited me to give a speech today. Honestly, I'm not a good speaker, but I can sing and paint, and I think I'm a little better at those. Anyway, congratulations. Congratulations to the students. You did it. I was really, really very surprised to see your presentation. It was very informative with a lot of culture. I like the artwork, and I'll talk about art later, why it is so important. So thank you so much and keep doing it. And I think if you have art and music with this science, you will go far and far. So I was asked to give an inspirational speech to you, but instead, your presentation and energy have inspired me. I am so proud of all your hard work and effort. I am very happy to be in front of you today. I have heard many good stories about Nepal from my Nepali friend at Bangladesh University of Engineering and Technology, but never had a chance to visit the beautiful country. It would be much better if I could come to your country today and stand in front of you and talk. However, in the future, maybe I'll have the opportunity to visit your country. In the current pandemic situation, everything is becoming virtual. Now, you have to learn how to feel and imagine. The smart COVID-19 virus of the modern age is forcing us to be smarter. Now, I have to realize that there are so many brilliant young scientists in front of me. When I went to middle school and high school, there was no computer, no NASA app challenge, no ISS, none of that. But we had many dreams. Today, you are fulfilling our dream. I congratulate those who are fulfilling our dream today and hope that it will bring more success for us in the future. You all are young right now. I can easily compare you with a space shuttle. You may be familiar with how the rocket works. The massive force generated by hot gases firing backward from a rocket engine produces an equal strength that pushes the rocket forward. Most of the fuel on board a rocket is used in the first few minutes of the mission to escape the Earth's gravity. Once the rocket is in orbit, it needs very little energy to rotate around the Earth. The video you will see now shows the phenomenon in action. So you saw that how this rocket worked. Since you are young and full of energy, this is the best time to gain as much knowledge as you can, which you are all doing now. With minimum effort, this knowledge will launch you into a successful trajectory in the orbit of life. The skills that you are learning today through the NASA App Challenge will help you gain knowledge. Keep going. Don't give up. One day, you will reach your goal. I'm here to say that you can be anything you want to be: a mathematician, a scientist, a doctor, a lawyer, an engineer, an astronaut, a rocket scientist, and so many other things. I'm one of the example. I was not good student when I was in your age. When I went to my engineering university, I was very actually lower than mid-level student. But I came to MIT. So if I can, you can do it also. You can even go to Mars. You just have to do work and believe in yourself. And never ever let someone else's limited imagination limit you. You have extreme energy, and what you can do is limitless. As I mentioned earlier, I'm not a good speaker, but I will share some of my own life experiences which may help you zoom through your orbit of life. Sometimes people ask me, How did I end up with MIT working on NASA's ISS based project? My answer always is my love for art, music, science, technology, engineering, and math helped me get here. We all know about the acronym STEM, which is science, technology, engineering, and math. I would like to add two more subjects to this acronym. And you also added one, and I think you added music too. I saw in one video you added music. So I want to add art and music with this stamp because artists are most influenced by the different aspects and situation around them. Through their endeavors to express this, they use different technique of creation consciously and unconsciously. The involvement of science, technology, engineering, and math for using these techniques is inescapable, which led to the argument of how scientists and artists collaborate and contribute in promoting culture and knowledge. Art, music, and STEM are related because all these three follow the same rule. I'll show some example here. If you look at the oil painting on the left side of the slide, it was done by famous artist Johannes Vermeer. He was the master of light. If you look at this painting carefully, it became so beautiful because of well-balanced contrast of dark and light. Some of you may know the legendary singer Muhammad Rafi, who is a all-time the best playback singer of India. One of his famous song is O Duniya Ke Rakhwale. It is my very favorite song. I will try to sing part of this song to explain the contrast of high and low pitch in this music. Bhagwan, Bhagwan, Bhagwan. ओ दुनिया के रखवाले सुन दर्द भरे मेरे नाले सुन दर्द भरे मेरे नाले आस निराश की दो रंगों से दुनिया तूने सजाई नैया संग तूफान बनाया मिलन के साथ जुदाई. See, I started very low pitch. Now I'm going up and slowly it will go up. नैया संग तूफान बनाया मिलन के साथ जुदाई जा देख लिया हर जाई ओ लुट गए मेरे प्यार के नगरी अब तो नीर बहाले. See, there's very contrast, low pitch and high pitch. That's why this song is, I think this is the best song of Muhammad Rafi. And I think the people who know this about Muhammad Rafi's song, I think will agree with me. Anyway, also, when you record song, you notice the song wave looks like picture on the right side. See the right side picture. It looks like similar to sine wave, which can be defined by STEM, which is science, technology, engineering, math. So I'd say art, music, and STEM are related. You need all of these three things to reach a point where you can fly. When I was very young boy, I had interest in everything. I have always loved every aspect of nature, the sky, cloud, river, water, green paddy field, flower, bird, airplane, train, etc. So often I used to go to pond to see my own reflection in the water, and I almost drowned twice. God saved me. It sounds dangerous, but my fascination with water helped me to understand reflection and refraction at a deeper level. While I was growing up, I had so many role models. Leonardo da Vinci, Michelangelo, Van Gogh,
Yes, sir, the great artist.
yeah, and my role models for science, technology, engineering, math, Galileo, Newton, Einstein. Einstein Newton was too big, and all three like too big for me. But they were my role models. And later on, I'll show that how I was inspired by these three scientists. But when I was busy with this art, science, and technology, I used to sing along with Muhammad Rafi, Kishore Kumar, Manna De, their Indian famous artist. I learned singing techniques from them. I never went to school for music and art. I just followed the people who were top in this field. And I used to watch Star Trek. In our time, this was the best space movie.
Space, the final frontier. These are the voyages of the Starship Enterprise. Its 5-year mission to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before. Captain's log, star date.
And later on, I was inspired by great mission, Apollo 11.
Since the dawn of time, people have looked up at the evening sky and dreamed of traveling to Earth's nearest neighbor. On July 20th, 1969, as Neil Armstrong started down the ladder to the lunar surface, a dream as old as humanity was about to come true.
So, this Apollo 11 and Star Trek inspired me most about space, and I started dreaming about the moon. At that time, I was missing telescope, and it was impossible for me to buy a telescope as I raised in a limited income family. Actually, limited income was a blessing for me. As you all know, necessity is the mother of invention. I used to love toys and I made my own toys. I didn't ask my dad to buy my toy because I know my dad's limitation. I made my mechanical robotics car, train, plane, helicopter, record player, cassette player, radio. I was not able to make enough thrust to fly my plane, but at least I was able to make plane to satisfy my need. Anyway, I decided to construct my telescope, but I did not have enough knowledge how to make this telescope. So I started learning. I started reading books about telescope lenses and did some research and development on light, lenses, and telescope. In the end, I learned enough to build a telescope. I learned about refracting and reflecting telescope, which I would like to share with you now. See on the refracting telescope, a big tube, and you put long focal length lens in the front, and here's the eyepiece. So your light rays coming from far distance, like let's say you're looking at moon, rays coming from moon far distance, and it ends up here in the focal point, we call focal point. And then we put eyepiece to make it bigger so that we can see the moon. With this telescope, you see opposite, like invert of the image. But later on, there's another telescope was invented, we call terrestrial telescope. So basically in that telescope, you put another lens here, which is this one, another lens, which converts the image. And finally, you see the real image, not inverted. So this is a refracting telescope I learned. Then I learned how reflecting telescope works. Reflecting telescope was invented by Sir Isaac Newton. He is my favorite scientist. So he used the reflecting mirror here. This is mirror, concave mirror. So light ray comes from far distance, and here it reflects. And then this is the focal point where all the ray converge. And then you put mirror here, flat mirror, which reflects this light ray. And you put eyepiece or microscope. And these days we put electron microscope to make it bigger, which is Hubble telescope. It's a similar concept as Newtonian telescope. So I learned all this, and finally I was able to make my telescope and started observing moon day and actually night, all night. I didn't sleep for a month. When I was first I made my telescope, I was so excited, and I saw the moon crater with my telescope. Believe me or not, I saw that. Anyway, so as a result of my personal role models and inspiration, in 1984, when I was in my University of Engineering Technology, some of my friends and some professors, they arranged an art exhibition where they brought all of my artwork, science work, everything was there. I was very shy. I never shared my artwork or science work with anybody. One of my friend went my home, he discovered, oh my God, who's Mizan's work. Then they brought everything in the university and they arranged art exhibition and they displayed everything, every little thing what I did. So in that art exhibition, this was the art exhibition they arranged. You see here a lot of artwork and sculptures. And on this side, I had all the science stuff there. So my professors, they were very surprised to see all this artwork and science work. And they were so happy. And they gave me gold medal. And I was surprised. Oh my God, our professor appreciates hard work. Usually engineers, they are more into technical side. Anyway, so after that, I was so inspired by our professors, my parents, my friends, and I continued my artwork. And I participated so many international art exhibition, and one of my art, this one, was nominated for the first place in 1987. An Asian art exhibition, you might know about that. Nepal, India, Bangladesh, Pakistan, Iraq, Iran, Japan, all countries participated in that exhibition, and my art was nominated for first place. Then I continued my artwork. I mostly during that time I spent more time in art more than technology. So I would share with you some of my artwork inspired by great people. This is I actually did after I joined MIT. I was so excited about space station. I did this artwork inspired by space. This one I was inspired by Leonardo da Vinci's Mona Lisa. These are sculptures. I was inspired by Henry Moore. He was a modern sculptor. This was a old woman in Bangladesh. She used to come to our house, and I did this. I was inspired by Michelangelo. You all know Michelangelo. He did the great sculpture of David. Then this artwork I did here in this I was inspired by Thomas Kincaid. He was a very famous artist in USA. This was, I was inspired by Picasso. You all know Picasso. He was master of Cubism. So I learned about Cubism, then I did this painting. In 1986, I started my professional career. My first job was assistant drilling engineer, where I learned how drilling works. And I also learned that this is very dangerous engineering because it can kill a lot of people if you don't know how how to do this. So there are a lot of techniques. I learned some of those from a great consultant, US consultant, when I was working in Bangladesh oil and gas company. Then I joined in another field, which is hydraulic power station. And there I learned hands-on power generation using hydraulic technique. So you see there are a lot of like cooling tower, condenser, water storage, feed water pump, see here boiler and turbine, and this is generator, we call alternator for AC. So all this technique I learned there. Then in 1991, I moved to USA. After working in Bangladesh for 5 years, I moved to USA for higher education and Texas A&M. And I did my master's in natural gas engineering, where I learned reservoir engineering, pipeline, gas pipeline, all those things I learned. But after graduation, and during that time, when I was in the university, natural gas engineering was very top category in the job market. But as soon as I got my degree, the market went down. So I didn't get my job in my field. And I ended up working for an injection molding plant. In my career, I never categorized myself only mechanical engineer or natural gas engineer. I accepted any job that were available for me at the time because I didn't have any option. So I did not stop. I continued my job. Whatever I got, and I accepted and started learning happily. And my first job was injection molding engineer, production engineer. And I used to do actually not only production engineer. I was so excited about this technique. I worked as a supervisor. I worked as an operator. I operated machine. I learned how to install mold, how to make mold, everything I learned, which helped me later on to invent my first US patented as molded plastic valve for gas pipeline. So then I worked for, sorry, I didn't show my injection molding. This is the injection molding machine, which I learned. You see, you have hydraulic fluid. You press plastic through this spiral, high heated barrel we call. Then you push inside the mold, and then you circulate cooling water, and finally you get your product. So I learned that, and I used that technique to invent my first US patented valve, which nowadays like in the developing nation, they use this in the gas pipeline. Then I started my journey working for different industry. Started from insurance, cybersecurity, Internet of Things, healthcare, patient privacy and security. I worked for Department of Defense contractor, where I secured their portal, and also I implemented patient privacy portal. So many different different areas I worked. And at one point I was thinking, what am I doing? What I'm I doing? I'm accepting anything that I see. I have to stop myself. Anyway, when I was like in 2012, when I was in Texas for 22 years. That time, my daughter just finished her degree in neuroscience. And one day she came to me and she said, Dad, I got research fellowship at Harvard. I said, wow. Then I was so excited. I said, okay, let's go. So she is my only daughter. So we decided to move from Texas to Boston after 22 years. I left everything, my house, my job, and everything I left for my daughter to help her in the research world. And it, because I never worried about my job or anything, because I learned how to live. So in 2012, we moved here. Then this was when I got the chance to interview for MIT Space System Laboratory. I did not have any experience with space technology, but I was not afraid of answering any questions. All my life experiences and hardship had prepared me for this opportunity of a lifetime. Then my journey at MIT started. Every day I used to go to MIT Space System Lab. I was so excited because this is totally new field and it was my dream. When I was little, I used to think about space. I always thought about, okay, I will be a scientist. I will work with like space. And I started working with smart people at MIT. My PI, principal investigator, was so smart. He knows everything about ISS robot, and I learned so many things from him. And like see on the left side, we are testing.
Spock, here's Einstein. We're back with you. Copy that, cheers. We've got LR enabled and Oleg's already reading through test plans, so we're ready to go.
Marshall, Jason, hi.
Great, we see him on video.
Hey, Alicia, can you put downlink 4 on output 84? Copy 40.
So this is our lab. When every day we used to test our robot with the help of astronaut inside the International Space Station, and also in the right side video, you see the astronaut. They are helping us to test our robot. This is called Spheres. So when I saw this ISS, inside the ISS, astronauts are helping us. Oh my God, I was so excited. I said, oh my God, you helped me to fulfill my dream. And I started working on the simulation environment. I helped the MIT Zero Robotics team to build the simulation environment. I worked day and night, and finally was able to run our Zero Robotics with our new simulation environment. And I want to show you here Zero Robotics final tournament. We used to run 2 tournaments every year, one for middle school and another for high school. And here you see
we have
students.
a lot of people here at MIT, and we have hundreds volunteers for all across the country, and they're excited because they got their code to send up to you, and you're going to run it for them on the Sphere satellite today.
Well, Drew and I are very excited to be part of this today. Congratulations on just reaching the finals of the 2018 middle school summer program for Zero Robotics.
See, in this Zero Robotics, what we are saying that our students' code we are uploading to the International Space Station, where the robot will be navigated using students' code. So they were very excited, and astronauts are talking to our student. So this is very exciting project for middle school, high school. Unfortunately, the students of developing nation, they're not able to join this Zero Robotics because they are not part of International Space Station. I tried to bring Bangladesh, India, Pakistan, right? And I don't know, Nepal approached us, maybe not. So in the future,
We have
in the future, we'll have opportunity to bring all this country, which we are working on right now. And right now, Zero Robotics in a transition mode. We are replacing our robot. Before we used spheres, which is old, 15 years old. Now we are using Astro B in the International Space Station. To use our new robot, we have to redesign this Zero Robotics again. Anyway, so with the Zero Robotics, I was able to meet all the great people here, as Mr. Rajendra Thapa mentioned the beginning. I met Greg Johnson. He works for Casey's. Greg Chamitoff. He is a famous astronaut. He was the one first. He talked to William Shatner, who was a main actor of Star Trek. He talked to him from ISS. And Kevin Ford, this is the astronaut I met first. When I joined MIT, I met this astronaut first, and I was so happy to meet this astronaut. And I was surprised that they're so humble and so highly educated, but very humble. And then I was lucky to meet this great astronaut, Michael Finke. And this is, I want to show this because all three astronauts are from MIT. I saw these three astronauts from MIT Space System Lab, and they talked to us from space.
Hello, welcome on board the International Space Station. I'm Greg Chamitoff, and these are my crewmates, Cady Coleman and Mike Finke. We're working with my favorite experiment on the space station, the Sphere's satellite.
So now, like I said, Zero Robotics uses the spheres, which is 15 years old. Now we are changing our robot inside the International Space Station, new robot called Astro B. There are 3 Astro Bs inside the International Space Station, and they will help the astronaut to offload their work. And this is just an example of Astro B. See, Astro B is moving, and it will try to find a leak inside the International Space Station. See, it is approaching, and it will find a leak and fix the leak. See, Astro is moving forward, and it will go here. Then it will fix this leak using laser beam. So this is we'll be using this Astrobe for future Zero Robotics. Now I want to talk about another project which I am personally doing for the developing nation. I realized that Zero Robotics is very inaccessible for developing nation countries. So, like I said, developing nation, they are not member of International Space Station, so they have to sponsor to join that International Space Station project. So I decided to create a platform for developing nation, which called STEMX 365. It has different lab like Spheres Lab, Astrobe Lab, CubeSat Lab, Art Lab, Orbital Mechanics Lab, Arduino Lab. So basically what I'm trying to do, like in the future, the students from developing nation like Nepal, Bangladesh, Pakistan, India, they will be able to use this platform with free of cost, and they will be able to write code to navigate these Astrobe spheres. And I have made this platform available for free for all students. Right now, I am deploying the platform in Bangladesh. In the future, I would be happy to host Nepali students as well so that they can learn more about ISIS-based technology. I hope you all enjoyed hearing about my life journey and way of thinking. If you want to accomplish a lot in life, remember to keep an open mind and hopeful heart. You have to be very open. You have to accept anything you face. And don't get upset or don't get worried about anything like, oh, I'm a mechanical engineer, I should be working mechanical. I'm an electrical engineer, I should be working as an electrical engineer. No. You can work in anything. But what I'm saying, you don't have to follow the same path what I had. I always take the challenge. This is my character. I always take the challenge. You can come USA from Nepal directly by British Airways, or you can fly to like Thai Airlines. You can from Nepal to Singapore, Thailand to Singapore, Singapore to Japan, then California, then Texas or Boston. So what is the difference? Difference is you are seeing so many things. You were in Thailand, Singapore, Japan, California, then Boston. He visited so many airport at least. So my path is that way. I visited so many places, so many companies, so many people that gave me confidence to face smart people like my advisor, my PI, astronaut, scientist, and now I'm able to work with all the smart scientists, and I feel like I'm a scientist too. Once again, I would like to congratulate all of you on your great achievements today. You have worked incredibly hard to get to this point, and your futures have barely just started. Your opportunities are limitless. I would you like to live with the best lesson that I have been taught while I was working with the incredible people on the ISS. This advice is from astronaut Michael Finke. Number one, be a good person before you become a successful person. Number two, work hard. Number three, dream big. Number four, never give up. Good luck and thank you so much.
Thank you, sir. Thank you for such an inspirational talk. I think we have got few questions. I think here attendee are here. They want to ask questions. Sansi, so can you please take on the floor?
Sure, sir. Sir, are you open for questions?
Sure.
Yeah.
I can
Okay, sir.
answer.
So, yeah.
Are you a student more smarter than other people?
So, because we are the future of this world, so we need to be smart, right? Yes, sir. So, anyone has any questions? Akriti, are you prepared with some questions? Yeah, sure, Akriti, please.
So hello everyone and hello sir. I had a question and it was and it was if I would like to be if I would like to be and if I would like to use my art in science, how would you suggest us to do it? How would you suggest us to use art in science?
That is very good questions. For example, now we are running Astrobe project inside the International Space Station. The use case is like Astrobe will find a leak. It's like fire service. When there's a fire, the fire service will just move in that point right away. So Astrobe has to go to that near that leak right away. But when it will move, it will see a lot of obstacle in front of Astrobe. So when you design, how you design this? If somebody asks you the right code for this Astrobe to find a leak where there are a lot of obstacles in front of you. So what will help you if you know the art? In art, you'll see we like, for example, landscape. Landscape, you think a lot of 3D. There are a lot of 3D objects. You think about shading, you think about top view, right view, front view, all these views. So if there is an obstacle, you have to imagine what is the x direction, y directions, z direction. You have to think, because you cannot create those obstacle in front of you. You have to imagine. You have to have imagination power. So when you do artwork, you make your imagination, and that is so powerful. And like, for example, when I did like a plane, telescope, and house, I played with a lot of 3D things. I played with objects. So you learn what is object. In programming, object is very important. How you create object. What is the class? How can you create object from a class? Like, for example, architect, they create the plan, But engineer, what they do? They take the plan and they implement, they make the house. So in programming also same thing. You create the class and as a programmer, you create object from that class. So this kind of imagination, these are imagination. If you are an artist, even if you are a singer, musician, you can imagine those things. And you can feel it. You can feel it. I hope I can answer, was able to answer your question.
Thank you so much, sir. And I hope, Akriti, your question was answered. Thank you so much, sir. Sir,
Yes, sir. Thank you very much.
I also have a question. So, you know that a lot of us are interested in science and physics and astrophysics. So, what skills, in order to, be prepared to go into real world and work in these fields, what skills do you think that we need to develop from this age?
Uh, this age, I think this is very good question. We'll be facing fourth industrial revolution,
Yes, sir.
and there will be big gap, and those gap will be filled by expensive people.
Mm.
They will come from another country, USA, Russia, China, Japan, where you have so many brains in Nepal. If you use your brain, if you train your young generation, which I love most, I love our young generation. They are so smart. If we give them opportunity,
Yes,
I think they will do a lot better than all the students in the modern country. Because when you have everything available, you don't get smart. You have to have hungriness.
yes, sir.
You have to have that passion. I believe the student in Nepal, India, Bangladesh, Thailand, Singapore, they have more passion than other students. So you ask me what type of skills we need. I think the skills we need, obviously, programming is very important because there will be a lot of artificials, machine learning, those things, data science. I think invest more time in those fields. That doesn't mean you will do only computer science. You have to have strength on other side also,
Okay, sir.
because every subject help others. These are interrelated.
Yes, sir.
So we have to make a model so that we don't have any gap on anything. Like when there people started working in computer science, there are a big gap in engineering.
Mm.
Civil engineers became computer engineer, mechanical engineer became computer. So there was big gap. So we have to think about that. We don't want to make big gap.
Yes, sir. Okay, thank you so much, sir. Sir, and my question was also answered. And I think we have another student, Sarvashri. Do you have any questions?
Yes, sir. Hello, sir. Hello, everyone. I'd like to
Yeah.
ask a question, which
Yeah.
is, sir, you have been motivated by a lot of things since your childhood, and I'd like to ask you that what was the thing that kept you going? I mean, in our age in Nepal, we would face a lot of problems, related to society, or we would feel down, or we will even I personally feel sometimes that I wouldn't be able to achieve my dream, what I dream for every single day, and sometimes we will not have enough resources to go for it. How did you manage to keep yourself going and motivating yourself? It's my question, sir.
Actually, it is a very good question. Uh, I am a kind of different kind of people. It's not normal. Like I try to keep my eyes closed. When I do my work, I keep my eyes closed. I don't look at others. I just do whatever I like, whatever I believe. I just keep doing it. And you know, um, my wife always teases me that she said, "You don't look at big things. When something very like tiny things happen, you're very concerned. So if elephant walks in front of me, I don't see that. So you have to keep your eye closed sometime. When you work on something, you keep your concentration and keep doing it. There will be a lot of um, obstacles in your life. You have to know how to manage those. It's not only financial, emotional, and a lot of things. You have to face every problem, and you have to accept every problem very gladly, because every problem, uh, like if like I showed you that if there's a dark, there's a light also. So it is temporary. If you see dark, you will see light no matter what. That is my philosophy.
Thank you so much, sir. You are a great source of motivation for our people like us. Thank you so much for your great speech and
Thank
your
you.
answer.
Thank you.
Thank you so much, sir. Sir, now we have another student, Sarbagya. Please ask a question.
Greetings, everyone. Sir, since I am passionately interested in music, my question is, how did music help you to grow as a scientist?
Uh, oh my God, you guys are smart. Asking very interesting question. Music, sometime we have to reboot our computer. Did you see that? Like if anything happens, like especially
Yes, sir.
Windows,
Yes, sir.
if there's any problem, it says common problem, just common solution, reboot. Huh?
Yes, sir.
Then sometimes we do like disk management, we defragmentation, those kind of things. So when you work on a programming or something very intensive and you use your brain too much, your brain gets tired. So what we do, it depends. If some people don't like music, they do other things.
Yes, sir.
But if you like music, that helps you to rearrange your brain cells,
Yes, sir.
and it will give you refreshment, like meditation. Like I mentioned that when I get too much tired, I listen that Muhammad Rafi's music, which is very soothing.
Yes, sir.
In your age, maybe there are a lot of good musicians. You can listen to those music and you'll feel it. You'll see that, oh my God, it helped me a lot to concentrate on my work. And concentration, which I always believe, you have to have full concentration when you do something. Close your eyes, just do the work, and music will help with that.
Yes. Thank you so much, sir.
Thank you
Thank
so
you.
much, sir. I hope your question was answered, Sarbagya. So now we have
Yes.
Amit to ask a question.
Did you say Amit?
Yes, Amit.
Yeah. Hello, sir. As you told that you had a great experience of working and learning different fields, different domains, yeah, such as space science, as well as defense, cybersecurity, and healthcare, and even finance. Sometimes in my life, I also face this kind of problem that I'm a great learner of computer science, and I have basically at first I learned website development, after which app development, and I'm currently learning cybersecurity and machine learning and data science stuff. And I also have to work sometimes in various fields like blockchain and disaster management for doing projects in ML and data science. So I sometimes feel that why am I doing searching and learning so many fields or domains? Besides, I'm interested in artificial intelligence and machine learning and robotics kind of stuff. So do you think it's good to research and learn various domains and to work in various domains? Beside from what you are actually interested in, how was your experience in working in different fields?
Yeah, this is also interesting question and hard to answer. So, like I said, it depend. Different people has different interest. I'm kind of person who likes everything. So it is very hard to stop me. Sometimes, if you like everything, like some people say, you'll be jack of all trade, but master of nothing. But I don't believe that. If you're really, if you put your concentration, like look at Leonardo da Vinci. Whatever he touched, it was master painting, master science, everything. Whatever you say, he is in everything. And there are so many other people, they did the same thing. They didn't come to the news or TV or they, but there are so many people like Leonardo da Vinci, even in this world right now. So if you have your interest in different field, it's not a bad thing. But sometimes you have to control because we have a capacity. We have a capacity. You have to control yourself sometime that actually it comes automatically. When you learn so many things over the journey, you'll find that, okay, my focal point is this. So now I can see my focal point. I was not able to see my focal point when I started. I was jumping different areas, different thing. Then I finally now I think I'm little more focused. So at your age, I think it is better to learn so many things, but like I said, sometimes you have to put break.
Yes, sir. Thank you so much. So we have another question from Tashi, and he asked that how are hypotheses made on various planets and stars, mainly about sun and black hole, and what is inside the black hole, and to what extent can our technology like confirm these hypotheses?
Oh my God, this is very hard question. I'm not black hole expert. All I know, the black hole, if something goes inside, it is done. It will not come back. And sometimes I feel like we are all inside the black hole. Who knows?
True, sir.
All the thing we're seeing in the TV and everything, these are mostly a simulation. Scientists' imagination. So black hole, if you look at the black hole like theory, you feel like me that, oh my God, maybe I'm also inside the black hole. So we are if we are inside the black hole and we are surviving, so how we will explain the real black hole? That is the question.
Yes, sir. Sir, so I guess we are done with the question and answer round. And
Ma'am, I have a question.
oh yeah, sure, please.
Okay, sir. Many people were thinking about going in moon and other universe and searching other planets for settling theirs. Is it better to leave the Earth and go settle in outside the Earth, or is it better to stay in Earth, making Earth as a better place for living?
This is another good question. When COVID-19 came in February, I posted on Facebook, what is important, COVID-19 or NASA sending people to Mars? I'm in space technology, but I was thinking, what is important for us? I think it depends. Right now, we have pandemic, COVID-19. A lot of people are dying, and still we don't have real good solution. I think we should spend more time to find a solution for COVID-19 to save our people first, because if you don't have people, what are you going to do with the Mars discovery, going to Mars? You have to make your people happy first, safe, happy. Then we'll go far. You have to make your foundation strong first. With that, I believe. So to answer your question, yeah, of course, we'll discover. We'll go Mars, we'll go Venus, we'll go other galaxy in the future. But we have to make our hometown safe so that our next generation can do more things and become more stronger, and that way we can go farther than Mars. Not anymore. Mars is close. Mars is not that far. I think we should go Andromeda. So we have to go to a galaxy.
Thank you so much, sir. I hope, Tashi, your question was answered. Now I think we are done with the Q&A round. Thank you so much, sir, for answering our questions. Now I would like to request
Thank you.
our local lead, Vijay Thapa, sir, to give us a thank you note. And
Thank you very
sir,
much,
are you there?
sir. Thank you very much. Within
Thank you.
short note, and then despite your busy schedule, we are very delighted to have you here, listening to your talk, such an inspiring talk. And the query of our students, I think they were fully answered and properly, and I think they find satisfaction in the answer. Sir, what takeaway we can, I think, take from your lecture is you are in yourself STEM. Science is also there in your life. Technology is also there. Engineering is also there. Arts is also there. Mathematics and music as well as is there. So I think now we have to write it as STEAMM, not only
Yes.
single M, sir. and then going through your life, you have been a real example that we see on the address of Step Job. He told that is how we connect the dots, and you have been a real figure connecting the dots. We are highly impressed, and it's our honor to have you here. I would like to give this opportunity to our COPSN members as well. So Sansi, anyone can come forward with the thank you speech for sir. Please, Sansi.
Sure, sir. Sir, I would like to take the pleasure to give a thank you note for sir who gave us this precious time. Being a high school student myself, I cannot believe that I am getting advices and getting instructions, suggestions from such big and inspiring personalities. Personally, I am very into arts as well and STEM as well. So I'm very confused, like, what should I choose? And what will society think about it, and will my parents will be accepting of what I am going to decide? But now seeing you as an example, I'm actually really pumped up to actually incorporate both art and STEM, and maybe create a better future for all the other youths that are, inspired by both of these sectors or more than that. So thank you so much, sir. You have been truly an inspiration for me, and I'm pretty sure that all of my friends agree with me as well. Your precious time is very much, we are very grateful for you giving us this precious time for us, and we'll never forget this talk, sir. This session was very incredible. Thank you for answering our questions. Thank you so much, sir.
Thank you. Thank you so much. Actually, how can I deny this invitation where I love our next generation? They're so smart. I hope our next generation will, like I said, they will fulfill our dream.
Sure, sir. We will try our best.
So many dreams. and you are all in my prayer.
Thank you so much, sir. Thank you so much.
Thank you.
Thank you so much, sir, for coming to COPSN and actually giving us kind of a blessing to our closing ceremony. And yes, we are ending this on a happy note. But just before ending this, we would like to show a summary video, like to indicate our journey in the NASA Space Apps 2020. Like, how did this journey happen? What did we come across, and how did we tackle different problems? So I would like to request our member Samrat to show the summary video to show a short reflection on our journey for the NASA Space Apps 2020. Samrat, if you're there, please press it.
Sansi, before that, two best presentation, you missed it, huh?
No, sir, after the summary video, right?
No. Before that, then we should summarize it.
Okay, I'm very sorry. I'm very sorry for the inconvenience. I'm very sorry. So yes, guys, we have had amazing presentations from our teams, from our global nominees to our regular teams. So now it is a big time. We are going to announce the winners. Let's say winners for the best presentations of the day. And we had sent a Google form where we had to rank the teams. And after getting a lot of response from the attendees, the participants, and the judges, we have done 50-50% of results, and then we have chosen the winners. So for announcing the winners, I would like to call Dr. Himu Kapli ma'am to announce the winners.
Thank you, Sansi. Okay, so it's a big time now. So who is the winner? Who can guess? Everybody is a winner, right? Okay, for this ceremony, we have to at least choose two of you guys. So the first winner, without delaying, you are since morning here. So without delaying, I'm going to announce the winner. The first winner of this NASA App Challenge 2020 goes to Martians.
Yay, Martians, congratulations. You guys had an amazing presentation.
Okay, so huge congratulations to you. And the second winner goes to NPS Robotics. Okay, so thank you so much for having also me here. And I also want to thank Mr. Chowdhury. I listened to his talk, and it was truly inspiring for us as well, not only the students, and that the journey you took to be there, the interest you showed in every aspect of the life which came to you, it was truly inspiring for us also. Thank you so much. Thank you all. Bye.
Thank you so much, ma'am. Thank you so much. Now, I guess, now that we have announced the winners for the presentation as well, congratulations to both Martians and NPS Robotics. I hope you guys have heard your results. And now, without any further ado, let's get into the ending section. Let's show the summary video. Samrat, if you're ready, please, let's show the video to everyone.
Samrat, we can hear the sound. Can you?
Providing science knowledge, information, science to the society. Is there cybercrime or no cybercrime? Yes or no kind of problem थियो, त्यही भएर त्यसलाई classification भनिन्छ.
Similarly, when you look other wars, you can actually see what went wrong and not let that repeat on Earth. For example, this is now Venus.
What is the power consumption of this microcontroller? This is very important because in space, we are limited by two things. One, the size. You cannot put everything that you want in this very small size.
Yeah, today I'm going to give a short introduction, not in detail, about the artificial intelligence.
It will reduce your confrontation, it will reduce your ego, it will reduce your time, and you'll have a high productivity and more constructive feedback also.
लास्टमा के हुन्छ भने नि आएर सबै दुईटै सफ्टवेयर आइसके पछाडि हाम्रो चाहिँ यस्तो भयो कि
So you might have heard the word Chorolpa, right? That's a glacial lake. And then people were afraid that Chorolpa would burst and then the Sunkosi River will swell. So
Okay, now this is like, I want to clap for this wonderful journey. Everyone, this has been an incredible journey. I am more than happy to be announcing that we have come to an end for this NASA Space Apps, but that doesn't mean that we're ending our problem solving journey. We are still very pumped up and hyped to go to different problem solving projects and actually bring different projects to you guys so that you can participate and actively, sharpen your brilliant minds and make all of us proud. So, guys, this has been a wonderful journey. NASA Space Apps 2020. We have smashed it. We have killed it. I'm so happy that we have come to an end of this in a happy note. On a happy note, we have ended this successfully. We have ended this successfully, and we have come up with amazing results as well. I hope you guys all had memorable accounts from this specific journey. I hope that NASA Space Apps was a wonderful time for you, and working with COPSN was also a very good time for you. COPSN is very, very grateful that you all were there to participate, to actively participate and show your enthusiasm, because without all of you being here, without all of our speakers, I think all this grand celebration today would not have been possible. And thank you so much for all the judges, for all the speakers, for everyone who has contributed in this program. Without all of you, this would have been impossible. So yes, thank you so much, everyone. Thank you so much for coming here. And on a happy note, we are finally ending this, right? So just to have a little fun and to make this remarkable, I just want to request to everyone to open the cameras so that we click a virtual picture and post it on Facebook or Instagram, just to close this on a happy note and make sure that and to say that yes, we have finally finished the NASA Space Apps and we did a great job. Everyone, please open your cameras so that we can get to click a picture and then post it on Facebook. Everyone, please, we will tag you for sure. Everyone, please. I hope you guys are opening. Oh, yes, all beautiful faces. Wow, I am. Thank you so much for coming today, guys. So I'll take a screenshot. 3, 2, 1, and go. Okay. Okay. We are done, guys. Thank you so much, guys. Thank you so much. Now, without you guys, it would have been impossible. See you guys next time, COPS, and we'll be coming back with more amazing projects to, sharpen up your brilliant minds. And thank you so much, the judges, all of our speakers, Mizanul Hoq Chowdhory Sir, everyone, our sponsors.
Thank you.
Incredible journey.
Thank
Thank
you
you,
all.
sir. Thank you. Have a good day and best of luck for everything.